Our final paper is SEI messages for coding video containing multiple constituent rectangles, being presented by Jill Boyce, who was a distinguished scientist at Nokia Technologies. Jill was formerly CEO of Weimers, distinguished scientist at Nokia Technologies. Jill was formerly CEO of Weimers, Chief Media Architect and Fellow at Intel, a Director of Algorithms at Video, and Vice President of Research and Innovation at Technicolor. She is a Fellow of the IEEE, recognized for contributions to video coding, and a longtime contributor to video coding standardization and an editor of the Versatile Supplemental Enhancement Information Standard. She has an MSc in Electrical Engineering from Princeton University and a Bachelor of Science in Electrical Engineering from the University of Kansas. Jill Boyce.
Hello. As John had said, I've been a long time contributor to video coding standards. And this is describing some work that I've done recently proposed to the standards. So I'm going to start talking a little bit about the motivation for this work. That there's a number of applications where you have a desire to have multiple synchronized videos together. There's a lot of different reasons that you might want, a primary picture and then something like an alpha channel or a depth map. You might have voltaic view. There's a lot of even other possible things for that. When I was at a startup before I joined Nokia, we were doing some things where we were having multiple views, but not full views, partial views. And we needed to use a non-standardized ad hoc proprietary way to handle it, because the existing standards, while they support having multiple layers, so if you want multiple pictures, you can put them in multiple layers, but the most common implementations of the video coding standards don't support multiple layers. So in my startup, we wanted to do something, and we still wanted to use FFmpeg, and we wanted to use built-in video video decoders that had software APIs available. So it's harder to be able to do multiple layers because the layers themselves do need to be synchronized. And so to avoid the need to have these proprietary ad hoc solutions, we're proposing a standardized solution that's flexible and can be used for a variety of different purposes, but is interoperable because it is standardized, to put these multiple different pictures within a larger picture. All right. So before I dive in too much about the particular thing, I want to give a little background to kind of level set everybody about what are SEI messages to begin with. So supplemental enhancement information messages have been around for many generations of video coding standards, going back to H.263. And they contain metadata that's inserted in a bit stream that's synchronized with the video. It could be on a sequence basis or an individual picture basis. And it conveys extra information that either kind of describes the bit stream or provides information that is intended for a decoder or receiver to utilize. For example, a post-processing operation. But they do not affect what's called the normative decoder operation. So video coding standards have a required decoder operation that they must match the values that come out of a reference decoder in order to be considered a conforming decoder. But SEI messages don't fit into that because they are optional to be used. So it's optional for an encoder. So many SEI messages have been defined to address particular use cases. But it's up to the encoder to determine, is it necessary or useful for my particular use case? And so an encoder can choose whether or not to apply it. But if the encoder does choose to include an SEI message in the bit stream, then they must follow the standardized syntax and semantics to be considered conforming. And then on the decoder receiver system, if it receives an SEI message and it doesn't want to process it, it's not required to and can still be considered a conforming decoder. But there's recommended behavior often that an SEI message provides. And so it's recommended that the receiver decoder takes this operation. And whereas the HEVC, VVC standards don't have a requirement for a decoder, application specs, such as, those by DVB or ATSC, can require the use of particular SEI messages for both the encoder and the decoder. And because there's no normative behavior of an SEI message, they're not mentioned in the definitions of a profile. So video coding standards have defined profiles, sets of tools that can be used. SEI messages are not mentioned in these profile definitions. I list at the bottom a few of the most commonly used SEI messages, buffering period, picture timing. The mastering display color volume is used for HDR, for example. Now I want to talk about how SEI messages are in the VVC and VSEI. So prior to the development of the VVC standard, SEI messages were included as part of the main specification. So in, AVC H.264 and in HEVC H.265, all the SEI messages are included inside of the main document. But in VVC, a decision was made to separate, and only a small portion of the SEI messages were included in the main spec. And those were those that kind of were related to picture timing and things like that. But all of the other SEI messages were put in this partner specification called VSEI, or Versatile Supplemental Enhancement Information. So why did JVET choose to do that? There are a number of SEI messages that are pretty much the same in multiple different standards. So you have it in AVC, you have it in HEVC, and then you needed it again for VVC, VSEI. One advantage of moving SEI messages into a separate specification is that they can be referred to and used by any video codec. And so whereas it's being developed along with VVC, HEVC can use SEI messages developed there. Even AVC can use SEI message developed there, and future video coding standards can as well. While I'm mentioning just the activity generally of the VVC and VSEI development inside of JVET. So the Joint Video Expert Team, or JVET, is the one that has developed these standards, or its predecessors. The predecessor organizations had different names, but it's joint activities between MPEG and the ITUT. And VVC itself is not developing new coding tools anymore. But yet SEI messages in VSEI do continue to be developed. And so new versions of VSEI are coming. In JVET, the main activity now is exploration work on a new, the future video standard, but there's no timeline for that yet. But the standardization of SEI messages continues on, and a new VSEI version will be coming. And the point I want to make about the lack of profiles mentioning tools and lack of normative decoder behavior is that new SEI messages can be developed, and they can still be used with existing implementations of profiles that predate those messages because they don't affect the core underlying normative decoder behavior. A little bit more background. One I want to mention is an existing SEI message that's called the frame packing arrangement SEI message that has been addressing at stereo views. If you had two stereo views, you could pack the two into a single picture. They were called constituent frames within a single picture. And there was a few options if you could do top, bottom, or left, right, or you could do a temporal interleaving. And when you only have two, those are kind of the options that exist. But the constituent rectangles SEI message, which I'm going to talk more about, allows more than two and provides more flexibility. So now let me tell you about the main topic here, which is the constituent rectangle SEI message. So what it does is it enables coding of a picture that was formed by compositing multiple other pictures that are referred to as constituent rectangles. I think the intention is that they were things that could have been pictures by themselves, but I guess any rectangle can be used. And these multiple constituent rectangles may be of the same type of content. You know, it might be multi-view content where you had multiple different views and they're all of the same type. Or it can include rectangles of different types. So you can have an alpha channel or a depth map along with a regular picture. And the number of constituent rectangles is flexible. The size, the position, and the number are all very flexible. The restrictions, though, is that they must be rectangles, and they cannot overlap within the coded picture. So if you had a sample position within the coded picture, it belongs to, at most, one rectangle and can't belong to two. But these composite pictures that we form with the multiple constituent rectangles, they can be coded in a single layer bit stream, so that it can be used with the most widely deployed profiles of HEVC and VVC. And this SEI message has been proposed for inclusion in an upcoming version of VSEI. And now it's been included in what's called a Technologies Under Consideration document, which means that it's being studied by the group in JVET, but there has not yet been a decision about if it will be included in a new version. And so the reason I'm here is to gather some input of if there are use cases of interest that could help justify including it in a new version of VSEI. So here are some examples of the type of content that can be included in the VSEI. So texture and alpha. You know, so I could do two rectangles. I call it just the regular video texture because when you have depth, it's often called texture. So I have a regular video and I have an alpha. I could put those two side by side. And whereas, you know, I could do this with HEVC or VVC already by putting those into separate layers, I would require the support of a multi-layer profile. So, but if I want to just put them side by side inside of this image, I can provide that information telling you this one's a texture, this one's an alpha, this is how they are located. Texture and depth, another example that's shown there. Both of these examples are, you know, having just two rectangles and side by side configuration. Of course, other kinds of examples can be done and different configurations. So here's an example of a multi-view use case where there are three views. If you look at these, and they're arranged in a, you know, vertical arrangement, if you look, you know, each one is like slightly offset, the same scene caught from multiple cameras at different camera positions. In my startup, we were doing things with virtual camera positions as well, and would have more views. So now I can have even more, where I can have multiple that are of the same type as well as multiple that are of different types. So this example is I have 6 rectangles because I have 3 views and each view has a texture and a depth. And you can see that as you start to have more than just 2, the layouts you might need to do different kinds of layouts because you don't want to exceed maximum picture resolutions. But you can start including more and more in them. One other example of how this could be used with another auxiliary type, VVC has and VSEI has an object mask SEI message where you can identify on a per pixel basis the object that a particular pixel belongs with, and then you can code in a separate picture a color representation of where each object is. And so if you look there on the right, you can see different colors representing the different objects. So you could put that other picture in a different layer, but if you wanted to use constituent rectangles, you could put them both inside of the same picture in a side-by-side basis, and then could be using those implementations that only support single layer profiles. Now I'm going to get into some more details of what is included inside of this SEI message. So first off is the number of constituent rectangles, and then the size and position of those. So the size is just a width and a height, and the position is represented by the XY position of the upper left pixel that's in that rectangle. And those are the only required elements to describe in the CRSEI message. But there's a number of optional parameters that can be determined for the particular use case, whether or not those would be considered useful. So the type, if I'm going to have alpha or depth or an object mask or image features or whatever that I want to do as a type, I can indicate a type. I can indicate an ID. So by default, there's like an index. If you start looping over all the rectangles, you can, assign their parameters. But maybe you have some reason that you would like to have some other numbers that were being identified. So you can optionally give an identifier. Another is that you can have an associated rectangle. So if you have like an alpha or a depth map, they're generally associated with another picture, kind of a primary picture. And so this allows you to indicate a primary rectangle that is associated with the current type of rectangle. And another option is a group ID. And this is particularly useful in a multi-view scenario, whereas a couple pictures back, I showed one where I had 6 rectangles with 3 views with a texture and depth for each. So, for example, you could say a particular view has a particular group, and then you could have a texture and a depth associated with that group. But it was labeled as being a group instead of just a view so that it was flexible for other purposes where you might be wanting to group some but not all of the rectangles together for some purpose. And then also there's an optional description of a constituent rectangle that allows kind of free form. So if the number of types that were described, the types are themselves listed inside of the standard. So if you have a type that is not one of those that's listed, you can kind of free form describe in text what you want to do for that, how you want to describe it. So it allows flexibility. And so you do have to send it at the beginning of a sequence, this SEI message, and then it persists for the whole sequence, and then you just need to replace it every time you have another iframe. So the signaling of the size and position, as I said, those are the key required parameters, are the size and positions. But there's several options that were supported in this SEI message to enable the encoder to address particular use cases and to be efficient in that signaling. So there's a subpicture one when subpictures are available. I'll say a little bit more about it on the next slide. Has a same size rectangles when all rectangles are the same size. And then there's an explicit signaling when neither of those cases apply, and you need to individually describe every one. And again, the rectangle positions may not overlap, so it can only be in one. And another point is that it's not required that every sample be in a constituent rectangle. It's just, they can't overlap, but they don't have to fully cover the entire area. Another thing I want to mention is VBC has a tool that's called reference picture resampling that allows you to change the resolution of a video sequence in the middle of the sequence without forcing you to put a new iframe. And so it's like if you decide, I need to reduce my bit rate, I can reduce the resolution and still do an temporal interprediction. So the RPR feature of VBC is supported explicitly in this SEI message by assuming that if you're going to downsample, you're going to be downsampling all those rectangles in the same manner. So for the sub-picture sampling, so sub-pictures is an optional tool in VVC that allows you to describe a breakdown of the image into sub-pictures that can be individually decoded separately from others. And so they already have a description of individual rectangles within the image. So if sub-pictures was used, then we allow in this Constituent Rectangles SEI message to just refer to those sub-picture ID values rather than needing to explicitly signal them. Another shortcut is what we call the same size signaling. So if all of the rectangles are the same size, then you can just send and they're all tightly packed in together, you can just signal the number of rows and number of columns of rectangles rather than having to explicitly say, oh, here, this is at this position, this is at this other position. Sometimes you could actually have gaps. Like I gave an example here where I have 3 rectangles that I was going to put in a 2x2 grid, and the bottom right here is gray because that's an empty sub-rectangle. I mean, an empty constituent rectangle. So I could still use same size signaling even if I have an empty type of rectangle. And the last option is explicit signaling. So with explicit signaling, you can have any kind of layout that you want. I showed an example here with a multi-view with 2 views with depth, but in this case the depth is quarter resolution. It's been downsampled half by half in each dimension, which is actually a not uncommon way to represent depth. So in that case, I can do an explicit layout of signaling, but I still do things for efficiency in a unit grid so that the kind of the smallest granular unit that I would use, I could do my signaling in terms of those units to be more efficient in terms of bit rate. So now we're talking about the status of this SEI message. So the Constituent Rectangles SEI, it was proposed to JVET in April of this year. And as I mentioned, it's in this Technologies Under Consideration document for consideration for future extensions of VSEI. And software has been made available for supporting this SEI message, and it can be integrated with the reference software that is used for VVC that's called the VTM. And encoder that wants to use it needs to give this configuration file telling it what the layout is. And it is proposed to be able to move this to a working draft for a new version and ultimately a new version of the standard. So in summary, this Constituent Rectangle SEI message, it enables a variety of use cases. VR, AR, 3D, 3 viewpoint, game streaming, cloud gaming, just many different use cases. And while existing standards can support a number of these use cases through multi-layer bit streams, some applications will prefer to use single-layer bit streams to simplify, timing, being able to utilize the existing, encoder and decoder implementations. And indeed, that was for me a motivation based on the work I did at my startup where we were needing to do this. And there was no standard method to do it. And we did it in an ad hoc proprietary way. So the proposed solution is very flexible, and it enables, these wide ranges of use cases that for which you do this composite. But then once it's actually standardized, it can be done in an interoperable manner. And so I would just really like to, my key request is just, giving feedback. If there are use cases of interest, help us justify moving things to the next generation. And actually, we're lucky to actually have us with it here. One of the co-chairs of JVET, Jens Reiter-Ohm. So we can tell him how that's interesting as well to move forward. Thank you.
So we have a few minutes if anyone has any questions for Jill.
Hey, Jill. Thank you. Fascinating. were a naive decoder to encounter this kind of content, what is the expected behavior?
If a naive decoder received it, it would ignore the SEI message and it would just display the picture. Oh, I wanted to go backwards, but it seemed to not work anymore.
The multi-tile?
Yes, you would see that multi-tile is what it would be, because it would be just seeing a picture that was, that had multiple rectangles together, and that is what it would see.
And is there an interaction with the sub-picture messaging that could say, no, naive decoder, please just use the top left corner or something on that order?
Right. So if you wanted to, basically, if you had the subpicture and these rectangles would be aligned with subpictures, if you were able to kind of have known that, I only want subpicture 0 or I only want subpicture 0 and 1, then that could be done. But that communication is not specifically defined. It would be kind of determined by the use case. But I think that if you were expecting an environment, there actually are other tricks you could do. Like you can do, having windows indicating display windows or something. So there could be some tricks, but I think in use cases, even though it is a standardized thing, it's better probably to know it's a use case that you have some expectation of what the behavior will be on the decoder receiver side.
Thank you.
Hi, my name is Fleming Lawrence, and I'm a PhD student at Arizona State. And my question is, I think this is great, by the way, and this is really good for the work we're doing with depth cameras and the way we're hacking together megaframes and splitting it into different channels. I have a question about the depth images, because they're usually 16-bit. And is there any standardized way for setting the subsampling of these different rectangles? So let's say the receiver knows that it's supposed to get a 16-bit number out of whatever, if it's a 422 per pixel, 16-bit per pixel, and subsample in a different way than the texture images, say.
Right. So in a coded picture, so this is an example of what would be the coded picture. And a coded picture only has 1-bit depth for the entire picture. So you do have some limitations. So if you want to be doing a 16-bit inside of a 10-bit or 8-bit, generally you do some kind of remapping of the depth to fit in within that range. I maybe could talk to you offline that there's a different SEI message I've worked on that's called a bit depth ranges, where you can actually split up some low order bits and high order bits into separate things, and they could actually be separate pictures or separate rectangles, constituent rectangles, so that you could accomplish that through the use of those two SEI messages together.
Okay. Thanks again, Joe.
Okay.
Thank you very much.